Hey, Mike from Prep Pros here. If you find yourself getting stumped on the second harder modules of reading and writing and math, this is going to be the prediction video for you. I'm going to do something new and unique. These are exclusively going to be predictions for those second harder modules. Now, if this is something you guys would like to see more of in the future, please let me know in the comments, or I may go back to doing predictions for both the first and second modules. Now, although we're going to be focusing on the second harder module in this video, I'm also going to add a bunch of bonuses we go through. We're going to talk about strategies and tips for these second harder modules, and I'm also going to talk about 5 bonus topics I expect you to see in the first module and some resources to help you improve on those. As we work through these questions, make sure you try them on your own and then watch the video explanation and see if you understand exactly how to do them. At the end of the video, I'm also going to talk about some additional resources and recommendations for you heading into your October SAT, especially for your seniors, because I know this is the final push you can make to improve your score for your college applications. All right, the first thing you're going to see on your test is probably one of the most confusing things that shows up on the SAT for many students, and these are these constant questions. Now, because these can feel so confusing, we're going to talk about 2 different approaches you can take to this type of question, and we're talking about another even more confusing variety that we want to make sure you're prepared for. Now here we see for the exponential function f, the value of f of 2 is k, where k is a constant. That just means it's an unchanging value. Which of the following equivalent forms of the function f shows the value of k is the coefficient or base? Now, most students' initial reactions when I work through these type of questions with them is they're like, well, how am I supposed to know what k is? The SAT doesn't define that, so it feels impossible to figure out the correct answer. But once we conceptually understand what this question is asking us, it's actually a lot simpler than it looks. So the value of f of 2 is k, where k is a constant, and k is the coefficient or the base. Well, this will always be your coefficient or your base. The other variety that I'm going to pop an example of on the screen is where it deals with a factor. If it's dealing with a factor, that means you're looking at the part in the parentheses. And at the end of the video, I'm going to talk about where you can find an explanation to that question. But for this one, we just need to essentially understand all the question is saying, when we plug 2 in, which one is still equal to this value that's preceding the parentheses? That's all this question is asking you at its core, because k is the coefficient or base. So when we plug 2 in, it's equal to k, it's equal to that value before the parentheses. Now, once we understand that, we can find our right answer a lot more easily, because essentially for it to still be equal to this, that value needs to be multiplied by 1. And therefore, we need to, when we plug 2 in for x, we're looking for which equation is going to raise 3 to the 0 power, because anything to the 0 is 1. So we're going to multiply that initial value by 1. It's going to stay itself. And that's why D is our correct answer here, because 2 minus 2 is 0, 3 to the 0 is 1. So that is still going to be equal to 59,049. Now there's another thing you can do with these types of questions to take advantage of them, and we're going to pop over to Desmos and talk through that. Now, the other way that we can approach this question is I just had to define all of these f of x functions as f of x, g of x, h of x, j of x, because otherwise Desmos will freak out when I start plugging it in. But since these questions are all equivalent forms, the other way you can sidestep this type of question to find the right answer very easily is you could simply plug 2 in for any of those functions, and what you will notice is no matter the function, they're all equal to 59,049. So all you're looking for to find your correct answer is whichever one shows that value is the value preceding the parentheses, that starting value, and that's how you can still see that D is correct, and you don't have to do so much of the conceptual heavy lifting. Now, the next thing you're going to see, although it's going to feel relatively simple once we go over the concept, this is missed a ton by students on the SAT, and it shows up in those late teens on the second harder module. And this is the concept of conditional probability. Now, you're going to know you're dealing with conditional probability rather than very simple basic probability, because you will see some sort of given statement. So given that the flower is a tulip, this is our red flag, it's conditional probability. So now we get to go through and we'll break this down. If a flower represented in the table is selected at random, what is the probability of selecting a flower from site A, given that the flower is a tulip? Now, this is our condition. Some students like to think of it as a restriction, because what this is saying is we're restricted to this portion of the table. Given that the flower is a tulip, what is the probability of selecting a flower from site A? So now we're just taking the site A out of the total tulips, 35 out of 50, or this will give us our correct answer of 0.7. All right, the next concept you're going to see has been one of the most frequent concepts on the second harder module. This has shown up on 3 of the 4 last SATs, and this is scale factors. Now, you can see it in a little bit more straightforward of a variant that we're going to start with here, or a really, really advanced variant like what I'm going to pop on the screen. But at its core, we still want to use the exact same concepts and strategies. Now, what makes these questions feel very difficult is there's some scale factor relationships that don't feel really intuitive for students. Now, going back to the core basics, scale factors are the multiple of side lengths in similar shapes. So if one shape has side lengths 2 times greater, that's going to be the scale factor. But where students struggle with these is those relationships, as I said, don't feel so straightforward when it comes to area multiples, surface area multiples, and volume multiples. Now the nice part, we have this table here that you can use, but there's also a really easy way that you can remember these. So we're just going to use the scale factor of 2 to teach it. So of course, if our side lengths are 2 times bigger, our perimeter in a shape is going to be 2 times greater. But now the easy way of remembering these other relationships is area and surface area are in square units. So if you want to find your area or surface area multiple, you have to square your scale factor. So that's why it's 2 squared or it's 4 times greater. Volume is in cubic units, so you need to cube your scale factor if you want to find your volume multiple. Now this also means if we want to reverse these, if we know an area multiple or a surface area multiple and we want to know our scale factor, we will take the square root of that value to get back to our scale factor. And if we're dealing with volume, we will take the cube root of the volume multiple between the 2 shapes to go back to our scale factor. So now go ahead and see if you can apply it to this example here, then we're going to talk through this. So here we see there are 2 similar rectangles. The area of the larger rectangle is 9 times larger than the area of the smaller rectangle. So this means, here we go, our area multiple is 9. So we want to work our way back to the scale factor because we're saying the perimeter of the smaller rectangle is 44. What is the perimeter of the larger? Well, that means since we know our area multiple, we have to take the square root of 9 to figure out that our scale factor is 3. So now once we know our scale factor is 3, all the side lengths are 3 times greater, we simply can do 44 times 3, and that will let us see that C is our correct answer. See if you can apply that to this trickier versions that I already popped on the screen before. Now, the next thing you're going to see are discriminant questions. There's 2 major types of solution questions you're going to see on the SAT. The first is going to have to do with quadratics, where you see an x squared term, and that means we're going to be using the discriminant. We're going to talk about the other variant where we're dealing with system of equations or linear equations later in the video. Making sure we can distinguish between these 2 is really important, otherwise students start to apply rules in the wrong place. So here in the given equation below, C is a positive integer. The equation has 2 real solutions. What is the greatest possible value of C? Like I said, once you see quadratic and we start talking about the solutions, that means it's a discriminant question. Now the discriminant is the part underneath the square root of your quadratic formula. But we really just want to have these rules memorized. And we're also going to talk about a way that you can cheat around some of this on test day if you struggle with doing it this more technical way using Desmos. But here, your discriminant is the b squared minus 4ac. If we have 2 real solutions, the discriminant is greater than 0. If we have 1 real solution, it's equal to 0. And if we have no real solutions, it's going to be less than 0. You don't have to deal with complex numbers on the SAT. So all we want to remember is it's ax squared plus bx plus c. So our a value is 4, our b value is negative 28, and our c value is just going to be c here. So all we're doing is negative 28 squared minus 4 times 4, 4a, times c, and we know this has to be greater than 0. So from here, we basically just start working through, and we get to punch this in our calculator and solve out the inequality. So when we do this, we will get 784 minus 16c is greater than 0. We can add over the 16c. So this is going to give us that 784 is greater than 16c. We can divide everything by 16. And once we do that, we will get that 49 is greater than c. So the greatest possible value of c is an integer, will be equal to 48. And that will be our correct answer. Now we're going to hop over into Desmos and talk about another way you can work around these questions using Desmos and a little bit of conceptual understanding. Now, if we're going to use Desmos to help us with these discriminant questions, there's one really important concept we need to understand with how we can apply Desmos. And that's that for quadratics, your solutions are going to be represented as your x-intercepts. So here when we're saying what's the greatest possible value of c, and we need to have two solutions, we need to see two x-intercepts. So we can work through with a slider with that understanding. We can do our 4x squared minus 28x plus c. So now we're going to add a slider. So now we're going to kind of zoom on out. We're going to try to make this as big as possible. So we'll push this like all the way up to 50 while we still have two x-intercepts. So we're going to go all the way here and it has to be an integer. So what we can see now as we're zooming in is once we make this 49, this is one solution. So here is how we can see in Desmos, the greatest possible value of c is going to be 48 when we work through. Now there's some other variants like the one that I'm going to pop on the screen that can get a lot trickier to do in Desmos when you have intersection of lines and equations. So these are really good to understand how to do by hand, because with Desmos, it starts to become a lot less reliable for students to be able to find the correct answer. If you've been enjoying the video so far and really learning a lot, I strongly recommend checking out my Ultimate SAT course. It's going to cover everything you need to know for the SAT. It's helped students get perfect scores. It's helped thousands of students make incredible improvements. It's backed by a 100-point score improvement guarantee, and it truly covers everything you need to know to get those incredible scores on the SAT. The bare minimum, you all should check out the free trial. No credit card is needed. And that is also going to feature detailed explanations to all of those additional questions that I've been popping on the screen. Now, the next thing you're going to see are percent questions, and these show up in two really common varieties on the second harder module. The first variety are these percent increase, decrease questions, and the second variety that I'm going to pop on the screen are these more algebraic questions where it's a little bit more work for you to work through them. But the percent increase, decrease is a little bit easier to learn, and students really often miss these even though they feel like they're getting them correct. So go ahead and pause the video and see if you can find the correct answer. Now, the answer that most of you probably picked is 900, and this is actually going to be wrong. So we're going to go back through the steps. Whenever you're thinking about percent increase or decrease, it's always expressed as 1 plus or minus if it's a decrease, plus if it's an increase, p over 100. So what the question is really saying here is 9 times what percent increase is equal to 81, so we can just use this formula. We can do 9 times 1, we're solving for x percent, 1 plus x over 100, we're solving for that percent, is equal to 81. We'll divide by 9, we'll get 1 plus x over 100 is equal to 9. We'll subtract over the 1. We get x over 100 is equal to 8. Therefore, x is equal to 800. Now, the next thing is a bit simpler than some of the other concepts we've gone through, but shows up a lot on the second harder modules, and it's a really good trap questions that students consistently miss. The first time students see this type of question, 90% of them miss it, and they miss it confidently. A handyman charges a flat rate of $218 for the first 3 hours of work, and $68 for each additional hour of work. Which equation gives the total amount y in dollars that the handyman charges for x hours of work where x is greater than 3? Now, I like to call these fake y-intercept questions because they give you a statement that feels like a starting value. They charge a flat rate of $218 for the first 3 hours of work and $68 for each additional hour of work. So students are like, oh, I'm starting at $218, and every additional hour, I'm going to charge $68. So like, oh, A has to be correct, and they end up missing this question and missing it confidently. Instead, the approach we want to use is we want you to just pull out 2 points from the equation that we can go and check the answer choices with. So we know for the first 3 hours of work, so x is the hours of work, so if we plug 3 in, the equation has to be equal to 218. And if we plug 4 in, each additional hour of work is $68 more. It's going to have to be equal to 286. Once we do this, we can just go ahead and plug in 3 for x, and if we do that, we can clearly see that a is not going to be equal to 218. Same thing happens with b here, and same thing happens with d. But we can see that c is correct because when we plug 3 in for x, it equals 218. When we plug 4 in for x, it equals 286. All you want to do if you see this type of question is simply turn it into a game of guess and check. You're simply going to create 2 points on your own, and you're going to plug them in, and if it passes both of those points, that's going to tell you how you found the correct answer. For most of these equations, you can simply pass with the first point, but it's always a good safety technique to have the second one to back it up. Now, we're going to break up the math, and we're going to talk about one of the most feared question types for students on the second harder reading and writing module, and these are these science passages. They're filled with complex relationships, overwhelming amounts of information, but we're talking about a strategy around these. And at the end of the video, remember, we're going to talk about general test day tips for these second harder modules. But go ahead and pause the video here and see if you can find the correct answer to one of the questions from one of our practice tests. Now, hopefully you've read all the way through, because I'm not going to read back through the passage, but the first thing we always want to do with these is I do recommend reading all the way through the passage the first time. And as you read through, just look for relationships across the different sentences and make sure you're understanding each sentence as you work through. The really important part is going to come once we find our conclusion. So climatologist Laura Van Grieken analyzed 2 ice core samples, one labeled G1 and the other G2, concluding that G2 formed during a period of cooler temperatures. Now, once we get here, we're going to go back to the part of the passage which is going to help us understand how we can identify that relationship. So we want to look back at the part of the passage. It's going to talk about what's making stuff warmer or cooler, and therefore we can really truly understand which answer is correct. And that's going to be these 2 sentences here. This is the big part we have to understand. Now, my recommendation if you start feeling overwhelmed with these passages or they give you relationships is to write stuff down. You're allowed to use scratch paper for the reading and writing, and it is incredibly helpful for so many of the students that I work with. So here we're going to talk about how we can break this down into simple notes. Since 18O is heavier than 16O, it evaporates slower in warmer climates, and therefore a lower proportion of 18O in ice cores indicates a warmer climate. So we'll just say warmer is just going to be our W, and that means we are going to see more of the 16O and less of the 18O. That's exactly what that sentence just says, right? We're having a lower proportion of 18O, so we're going to have a higher proportion of 16O. The inverse holds true for cooler climates. So for cooler climates, we're going to see less of the 16O, and therefore we're going to see more of the 18O. Now, the reason that writing this stuff down is so helpful for students is keeping these 2 things straight in their heads often feels tricky, and as students start to look at answer choices, they start to lose track of the relationship they're looking for. So if you write it down, it gives you something very simple you can check the answer choices against. And if we do this, we can see exactly why C is correct, because it's saying exactly what we just said in our notes. An isotopic analysis of the G1 ice core revealed a higher ratio of 16O to 18O than the ratio revealed in sample G2. Well, we know if it's warmer, we're going to have more 16O and less 18O. So therefore, if G1 has a higher proportion of 16O to 18O than G2 does, it's going to be warmer when it's from G1, and it's going to be comparatively cooler for G2, and that's exactly what we need to see, and that's why C is correct. Now we can look at all the other answer choices. Now A, an isotopic analysis of the G2 ice core was found to be from a period where there was an unusually high amount of evaporation. Well, we need to be making a comparison between the 2 because that's going to be supporting it. G2 formed during a period of cooler temperatures. Well, we need to compare to G1. This does not compare to G1 at all. Same core issue with B. G2 ice core showed an absence of the oxygen isotope 18O, but also we'd want to see more of that for it to be cooler. That's another way we can rule that out. D, an isotopic analysis of the G2 ice core showed a similar amount of 16O to the G1 sample, but showed a lower amount of the 18O than G1 did. Well, that once again is going to be opposite. Now, if you're looking for practice tests that are truly representative of the difficulty of what you're going to see on test day and have very challenging second harder modules that are ultimately going to make test day feel comparatively easier instead of the blue book tests that often feel quite a bit easier than your real test, make sure to check out our practice tests. You can check out the first one for only $10 with the code below. Now, the next thing you're going to see on your SAT are what I like to call advanced unit conversion questions. So this is unit conversion with either squared or cubed units. It can be in slightly easier versions like this, or really challenging versions like what I'm going to pop up on the screen. And all of the questions I've been popping up on the screen, you can find explanations to in the advanced portion of the free trial to my Ultimate SAT course. There's no payment, no credit cards needed, so you truly can go in there, and I definitely recommend checking out all of those advanced questions because they'll really help you out in the second harder module. Now, the part that trips up a lot of students with these is they treat it like a very simple basic unit conversion question where we have 32.8 square miles, so they do 32.8, and then they just do miles, and they'll do it over 1. And then they're like, okay, well, I need to cancel out the miles, so I'll do my 1,760 yards over 1 mile. Now, the important part to take note is if you see squared units or cubed units, you're going to need to square or cube your conversion factor. So how we really want to write this is 32.8 miles squared, because once we do that, that's going to let you understand that you need to square this entire conversion factor, because we're going to end up with yard squares over miles squared, and those will properly cross cancel. So all we're really doing here is 32.8 times 1,760 squared, and that will give us our correct answer of D. Now, before we talk about this next tricky grammar question type, I strongly recommend pause the video and see if you can find the right answer. Now, what I like to call this is hidden extra information. Now, extra information are phrases on the SAT that you can place commas around and you can remove from the sentence. So very simply, if you see two commas around something and if you remove it and it makes sense, that basically tells you those commas are necessary or needed. Now, the way that you can spot you probably are dealing with one of these types of questions is you'll see some answers will include a comma and some will not. If you see that, you want to be on high alert that they may have a huge piece of extra information you have to watch out for in the sentence. And your confirmation that you're dealing with this is you will see a comma later in the sentence, and your full confirmation is you will see a verb directly after that comma. Because what's really happening here is everything from this comma to this comma we can remove from the sentence. And as we go through, we can reread the sentence. The Berlitz method is a language learning approach that focuses on speaking and listening skills over grammar rules. That makes perfect sense. We removed everything between the two commas. That's how we can tell it's correct. Now, the issue for so many students is if they aren't looking out for this or they aren't aware of this concept of extra information, they'll just read through, and all three of these are going to sound a lot better to your ear naturally than D will. And that's what really trips students up. And this is just kind of a good note for these standard English conventions. If you are doing these based off what sounds right or feels right, you are going to struggle, especially on the second harder module. At the end of the video, I'm going to talk about some resources that I would definitely recommend you work through before your SAT so we can really improve those core skills and make you start to understand what's really happening with these grammar questions. All right, the last concept we're going to talk about, we hinted at earlier in the video, and this is going to be the no solution questions with system of equations. So we're going to talk through this. We're going to go through resource recommendations, where you guys can find explanations to those questions from earlier in the videos. And then at the end of the video, I'm going to talk about general strategy tips that I discussed with all of my students. So make sure you stick all the way around till then. So here, if we see no solution, the conceptual understanding we want to have is this means we're having parallel lines with different y-intercepts because they can never intersect. Now, there's two different ways you can approach these by hand, and then we're also going to talk about a Desmos trick, which can be really helpful for these if you struggle or this feels a little overwhelming. So we could have put these in y equals mx plus b equations and then do the slopes equal to each other, and that would solve for no solution. Or the trick that usually feels more comfortable for most students I work with is if we can put both of these in standard form, if the slopes are the same, the ratio of a to b must be the same for both equations. This is actually such a tricky question type that we've dedicated an entire chapter in our book to these because these do feel very weird and students miss them all the time. But once we get that conceptual understanding down and what we're looking for, the question isn't too bad. We're going to go through the method that I prefer, which is put these in standard form, and then we're just going to use those ratios to make sure the slopes are the same. So we're going to subtract over the 48y and we're going to add over the 12x. So this is going to give us 48x minus 112y is equal to 24, and this will give us that 12x plus ry is equal to 1/8. So all we have to do is set up this ratio. We're going to simply do 48 over negative 112 is equal to 12 over r, and when we cross multiply and solve through, we're going to find that r is negative 28. Not too difficult. The reason I don't typically recommend to do the y equals mx plus b is you're creating more steps where we can start making more mistakes, and I often see students mess up somewhere along the way doing that. In this, I see students be much more consistent with finding the correct answer. Now, not the preferred way of doing these, but you often can still find the correct answer in Desmos with a bit of guess and check once we have that conceptual understanding these are parallel lines that are never going to intersect. So I would do like negative 50 to positive 50 if I was just totally guessing and checking. Then all you're going to do is you're going to move this slider around until you start seeing parallel lines. And what we can kind of see here is, right, we know negative 28 is the correct answer from doing it by hand. We can see these are never intersecting here. The way you can kind of confirm that's your correct answer is once we go a little bit beyond, We can see they intersect up here. And even, let's say we did like negative 28.2, you'll start noticing it gets closer here and a little further here. Or if we do negative 27.8, closer down here, further up here. So looking at those extreme ends can help you better judge whether something is truly parallel or not. Now, before we wrap on up, we're going to talk about bonus concepts I think you're going to see, resource recommendations, and then general strategy tips for both of those second harder modules. Now, handful of different additional topics that I think you're going to see. The first thing is be very careful with the notes questions. The old advice that you can just simply read the question and go straight to the answer choices and find the correct answer no longer applies. You have a very high likelihood of having to assess the accuracy of some of the notes to figure out which answer choice is correct. Now, the next thing that I absolutely know you are going to see both in the first module and you have a very high probability in the second module are questions testing you on the understanding of independent and dependent clauses and the ways to join them. So if you look at questions like this or this, and you're doing these based off of what sounds right or feels right, please check out the free trial to my Ultimate SAT course. We have an entire unit on those. And mastering these skills is the most important grammar skills that it can improve your score 30, 40 points on reading and writing. Now, the next thing that I think you are going to see are two types of system of equation questions. I'm going to pop both of those on the screen and also the particular questions in our free trial that correspond to those. Once again, for the free trial, it is truly free. You do not even need to enter in credit card details. So it's an amazingly helpful resource you can use before the test. And the final thing that I think you will see will be question number 1 in the advanced portion of our free trial. And these are tricky trig identities. Now, some general recommendations for all of you. Please check out that free trial. There's over 2 hours of content in there. It can really help you improve. Students have gone through and stated they've improved 50 points just by working through all of the content in there. Now, a few other recommendations. If you are starting to get close to your SAT, you haven't done the greatest job of studying, and you just want to cover all of the topics that show up on every single test and improve your score in the easiest way possible, check out our SAT crash course. If you have more time on your hands and you want to cover a lot more content, check out the Ultimate SAT course. This includes our advanced math courses, practice tests, all of our reading, writing, and math courses, so it can make an incredible improvement on your score even a short period of time if you have a good bit of time to dedicate to it. Now, if you are just struggling on the second harder math module and you want a lot more practice with the real type of questions that have been showing up on past SATs and they are repeating these types of questions, definitely recommend checking out our advanced math courses. And if you want more practice tests, these are included in our Ultimate SAT course, but you can also purchase them individually. Now we're going to talk tips for those second modules. Now, I don't want to be changing anybody's strategy heading into the test, but I always recommend saving the reading questions for last, whether that means you're doing the vocab questions, the standard English conventions, the transitions, those notes questions, and circling back to reading, or doing the grammar through notes and then vocab and reading questions. But either way, be very cautious of sitting on particular reading questions for too long. General tip that I always like to remind students of for reading and writing, especially if you're feeling comfortable with the rules and you've done a lot of practice, do not change your answers unless you have a really good reason for doing so. For most students, if they start changing their answers on reading and writing, it's because they're selling themselves on a wrong answer. So be really cautious of that on your test. The other really important tip, the last handful of reading passages are going to be very complex, very dense. If you start getting squeezed for time, do not start panicking and rush. Instead, spend the time getting the questions correct that you can. It's okay to not answer 1 or 2 questions on reading, and you're going to do better doing that than starting to rush through a handful of questions, and you're probably not going to get any of them correct. Now, for the second module of math, and this also goes for the first module of math, the really simple test day advice without getting into a ton of teeny tiny details that I give students is make your first pass answering all the questions you know how to do. The number one killer on test day for students with the math section is they will sit on a question for like 4 or 5 minutes. They'll look up at the clock. Panic will set in. They'll start rushing through questions, making mistakes they don't typically make. So be very cautious. If you hit the 60-second mark and you don't know how to approach a question or where you should go, bubble in a guess, move forwards, and then if you have time left over, come back to it. You want to let yourself see all of the questions on the test. Now, if you are trying to score super, super highly on math, there is one other important thing to watch out for. The first 8 or 9 questions are typically going to be relatively easy in the second module for you if you're looking to score that highly. Avoid double, triple checking your work, or you're going to start having timing issues you don't normally have if you're not typically doing that on practice tests, and most students aren't. You're going to have to go a little fast through those easy questions because the test is really going to start to slow down in the late teens in those 20, 21, 22 questions. Now, I really hope this video has helped you guys out. If you have any questions, as always, please drop them in the comments below. If this helped you out, a like, a subscribe, leaving a helpful comment is always really appreciated.